Find the period and sketch the graph of the equation y equals secant 2x. Well, we know by the reciprocal identity that secant 2x is equal to 1 over the cosine of 2x. And so if we can sketch the graph of cosine of 2x, we could take the reciprocal graphically to get a sketch for the secant of 2x. So let's consider the cosine of 2x. The period for that can be found by doing 2 pi, the period of an unchanged cosine curve, divided by the coefficient of x, that's divided by 2. That gives me a value of pi for the period for the cosine curve. And if I look at the interval from 0 to 2 pi for the argument of cosine 2x, I have this, and if I divide everything by 2, I have 0 less than or equal to x less than or equal to pi, and we can see that the first cycle for the cosine curve will happen on the interval from 0 to pi. So let's sketch that. I have I'll mark a pi here on my x-axis, and I'll mark 2 pi. I'm also going to divide this interval where one cycle occurs into 4 pieces. That of course gives pi over 4, pi over 2 is the middle, pi over 3, and pi. And the cycle for the cosine will have a max of 1, and that will occur at the left end point for this interval we found. It will reach a max of 1 again at the right end point of that interval, and it will reach a minimum of -1 halfway in between, which is down about here. Halfway between this minimum and this maximum will be a 0. Similarly here we'll have a 0, and the curve will look something like this. We can repeat that on the next block of pi units. We'll have a minimum here. We'll have a maximum again at 2 pi. I'm just shifting to the right pi units for all of these points. There are 2 cycles of cosine. I could go back to get another cycle. This would be at minus pi over 4, minus pi over 2, minus 3 pi over 4, and then minus pi. Gets us to here. That should be enough to give us a good sketch for the graph for the secant curve, because the secant is just the reciprocal of the cosine. And so in order to graph the secant, what I'll do is take the reciprocal of all of the relevant points that I've found. Notice we found zeros for the cosine curve, and if I take the reciprocal of a 0, I get an undefined quantity. That'll give me a vertical asymptote. So at all these zeros, I'm going to have vertical asymptotes on my secant curve. I'll sketch those here. And anytime the cosine is 1, when I do 1 divided by that, I'll have also 1. Right? 1 divided by 1 is still 1. But as the cosine curve falls towards 0, it's going to tend to blow up towards plus infinity, and I'm going to get all these cup-shaped regions. Here I have negative cosine values. The reciprocal of -1 is still -1, but for all these fractional values for the cosine, those will produce large negative fractional or large negative values for the secant, and this pattern will continue on each of the branches that span the vertical asymptotes that we've sketched. So here's an approximate sketch for the secant curve that we were asked to identify. The period for that secant curve will be the same as the period for the cosine curve that we found. That period